Alright, hello everyone, welcome back to the channel. My name is Danny, and today we're going to talk about error handling in Rust. So, I think this is one of those topics that a lot of people, myself included, kind of glossed over as we begin our coding journey because it's not fun, right? It's not sexy. Like error handling, like, we just want to get to the code, we just want to see all the juicy, beautiful, optimizing stuff. Like we don't really care that much about error handlings, but same with my C projects back then when I used to write a lot of C code. I would just always just return null, or null pointer, and I would check, if result equal null, then I would print out a string and then return back to the main function. But after this weekend, I was studying from Green Tea Coding and another article that was written by Burnt Sushi, and I'll leave the link in the description. And it really opened my eyes, and it's really fascinating to me how error handling can be so deep, and you can really get down to the nitty gritty. And I think that as a software engineer, it's very important for us to understand what errors means, how we can write good errors and informative errors so that our code base can be maintained way after we're gone. So without further ado, let's get right into it. Alright guys, so as you can see, I have a blank Rust project here. I already have all of the modules, all the crates, imports, everything up here. That way we're not, scrambling, trying to find certain ones, wasting time. What I want to do is just to create a function or a program, so to speak, a small program that will open a file and read whatever's in that file and extract the string from that file, convert it into an int, and then multiply by 2 and then just return the number, and we just print it out to the console. Very simple stuff, but I'll write the code so that we see the progression of our error handling so that we can see what each stage looks like and how we evolve from a very primitive slash basic slash probably insufficient way to handle errors all the way until production ready, good code that we can be proud of, especially with the way that we are handling these errors. So first of all, let's go ahead and make a function here called file double, right? And it's going to take in a file path, just going to be a string slice for now, and we'll return an I32. Okay, and what we're going to do is we're going to say let mute file equal file open, right? And we're going to pass in the file path. Pretty simple stuff so far. As you can see, it's going to return a result, right? A result is the same as an option. Result and options are kind of one and the same. An option display, it basically has a possibility of an absent, right? Of an absent of value is an option. Option is either some or none. However, a result is either okay or error, as in if it's okay, then we can extract the value within that okay and we can use that value. But if it's an error, then there's an error inside of it and we need to extract that error and handle it however we see fit, right, as programmers. So for now we're going to use unwrap. And as you write more code, especially as you write more code in Rust, you're going to realize that unwrap is actually not a very good way to handle errors, because all it's going to do is panic. A panic is simply a way for it under the hood. If you look at the panic function, all it does is just basically use the arms, the match functionality, just try to see what it is inside of this value, and if it's an okay, then it'll unwrap that value of okay and send it back to us. But if it's an error, all it's going to do is panic, meaning it's just going to exit the program and print out a very vague, error message that is associated with that error. So and also, I don't know if you guys noticed, but recently there was a big hack that involved unwrap in Rust. So that's a different topic. But yeah, basically you typically do not want to use unwrap in production, right? You can use it if it's just trying to get some quick and dirty code going, trying to establish an application, trying to get something done really fast, or you're trying to demonstrate something. But as far as production code and good code, you really don't want to have unwrap. You want to handle these errors gracefully. So we're gonna open up a file, and as you can see, the file is now a type file because we already unwrapped it. So if there's any error, it would have panicked by now, right? So the next one is gonna be a string. We're gonna call it content, and we're gonna create a new string here, right? And then after that, we're gonna say, let's see, file.read to string, right? And we're gonna send in that mutable reference of the content, because that's going to be the buffer that is going to read to. And let's see, read to string, definitely. We'll make sure we unwrap that as well, right? Yeah, and then after that, we can go ahead and take the content, the strings inside the content. We're going to trim it so that any leading and trailing spaces, it's going to be taken out. And then finally, we're going to parse it, right? Parse I32, we want to return I32, and we make sure to unwrap that as well, and that's gonna have to be kept inside of a variable of n. So n is gonna be whatever the remaining integer is if no errors occur, right? Like if that error occurs here, then we would have called unwrap, we would have panicked, and we would have exited the program. But if we didn't, then we have the n value returned to us, and we're just gonna multiply that by 2 and return that to the caller. Okay, so now in the main function for this one, I'm gonna say other code functionalities, right? And on top of that, I'm gonna say print line, and we're gonna print out file double and example.txt. Okay, and we're gonna there it is. We're gonna create a new file called example.txt, and in here we're just gonna leave a simple 100 integer that's going to be read as a string. And so our program is going to open that file, extract the content into the buffer here, into the content of string as string, and then after that we're going to parse it, we're going to trim it, and then parse it into an I32 integer, multiplied by 2, and that's it. And that should be it, right? Okay, so let's test out the code. Call go run. Okay, so as you can see, it returned 200. We printed it out. Let's say that, and then other codes after that can work, right? Can continue to run as normal. However, this is the problem with unwrap, is because a lot of times we might have an error that's not exactly catastrophic, and we don't want to just panic and crash the entire program. Something like this, maybe we can handle the errors a lot more gracefully and allow the other code to run normally instead of just crashing. And for example, if we say example2.txt, it's not going to be able to find that file because there's no such thing as a file called example2.txt inside of these directories. So it's just going to panic. Yeah, see, so it's just going to panic. It's going to leave you with a very vague vague error message here that's not very pretty, and then as you can see, this line never got executed. So it wasn't very gracefully how we handled the error. And for this video, I really want to help to get you guys to understand that we can do a lot better than this, and we're gonna progress, like I said, down the line, and we're gonna get to better and better and better until we finally get to the final stage where our code is pretty much production ready and the error handling is on point. Okay, all right guys, so let's keep going. As you can see that this was not adequate, so we're gonna go ahead and introduce a new concept of result into our function. So instead of returning an I32, what I want to do is return a result instead, and within that result, the OK variant is going to contain the value inside, and if it's an error, then it's going to be an error variant with, let's say, a string for now. Okay, so we'll start with a string. So here's a neat trick for you to shorten up the instead of writing result error all the time. We could use a type alias and say result t, which is whatever generic type that's going to be within the result. It's going to be an std. I think we're going to use a result type, so it's going to be std result, and then we're going to pass in the t in here for the OK variant, and for the error variant it's always going to be a string. Okay, so what this does is it shortens all of this into this, so that all we have to do is just type result and whatever type that we want to put in, and that type is going to be within the OK variant, and the error variant is going to be fixed with the string value inside of it. Okay, so we're always going to return a string for a value if we encounter an error. So in order for us to do that, we're going to go ahead and take this out, and we're going to say result I32. So there you go. If it's an OK, then we're going to return an I32, but if not, we're going to return a string as an error, right? And what I'm going to do is I'm actually going to comment this out because I want us to come back later and see the progression of our code, and you guys be the judge of which one you think is a favorite, or which one looks the best, right? Or looks the most the most aesthetically pleasing, so to speak, and also the most production ready, right? So for this one, let's do something like let mute file equal match, right? File open file path, right? And then we're gonna match the two arms. If it's gonna be an OK, then we'll take the file, right? And we'll do something with it. But if it's an error, then we're gonna convert that error into a string. So error dot to string. Okay. Let's see here. What we're gonna do with the file? We're just gonna return the file. How's that? Is that okay? File. Yes. Error to string. Oh. Yeah, we're gonna have to wrap that inside of an error variant. What is it? What is it? What is it? Incompatible types. Enum result string found to be found type. Okay, file, okay, match file, or it's going to be return. Okay, there you go. We're going to early return that, and if not, then we're going to do the same thing as earlier. We're going to have a mute contents equal string new, and then we're going to take the file, say read to string mute contents. And instead of unwrap, we're gonna say if let error equal file dot read to string. So if if file dot read to string returns an error, then we're gonna return an error variant error dot to string. We're gonna have to encapsulate that as well in here. Right? Does that work? It's weird because in C we don't have if let error. You know, this is kind of weird to me still, writing Rust, because in C I would say if parentheses file dot read to string blah 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 equal error close parentheses, and then, but in Rust it has like this backward logic. I've never seen this in any other language, so it's kind of strange. Okay, so then now we have that. We have the contents, which should have the string of whatever it is that we were able to extract from the file, and we're gonna say contents dot trim dot parse I32, right? And then we're gonna have to return that. So it's also gonna be a match. So let n equal match, right? If it's an OK, then I think okay, then we return the n. It's gonna be a sum. We're gonna wrap that inside of, I mean not a sum, I'm sorry, an OK variant, so that we can return it to the caller, and it's gonna be n times 2. Okay, but if it's an error, then we're gonna return error dot to string, right? Because it's gonna be a string every single time. Okay, is that okay? Okay, no. Actually, we're not gonna do anything with this n. Okay. I32. We're gonna help it. Okay, if we don't want to do anything with that, what do we do here? Okay, so that should work. Let's see if this code works the way it is. Oh, so hold on, let's go ahead and get the right example first. Formatting default. Oh, okay, this has to be double I32 I return. Oh, okay. Oh yeah, so we got to convert this main function as well into an a match function. So we're gonna say let result equal file double, right? It's gonna be example.txt, and we're gonna say match here. If it's an OK variant, then we will take the n and print it out. If it's an error variant, then we will take that error and print it out as well, because it is a string. Okay. Okay. Let's see. Okay, so as you can see, everything is working normally again. Now the difference with this is, if we use a wrong file path, right, and it can't find the file, it will just print out the error and continue with the other code, right? So it's not gonna panic, it's not gonna exit the program early. It's gonna do what it's supposed to do by handling the error, printing it out. As you can see, the system cannot find the file specified, and then other code functionalities follows after. The same if we were to use, like, we put a string inside of the 100 so that it can't parse it correctly, it would do the same thing. It would say, oh, I can't, invalid digit found in string, and then other code functionalities. So as you can see, this is a much better way to handle the error than using unwrap already, right? Even though this is not perfect, and the reason being is because this is called case-to-case analysis. We're using a lot of matching here, a lot of different arms, and it's just not very pretty inside of the code, and it's just very tedious. And you know, I don't know, I don't like this version. I'm not going to say that it's wrong. I mean, there would be time when you would use this kind of coding style, but for me, I think it's not that great. I think we can do a lot better, right? So we're going to comment this out. So the next step we're going to do is we're going to use something called map.err. So map.err, what it's going to do is it's going to take the error value inside of the error variant of the result, and then whatever the closure is that you pass into it, it's going to work on that error value and then return it, right? So instead of map, which takes the OK variant of the result and then take the value out of that OK variant and work on it with whatever closure that you pass in, map.err is going to do the same exact thing except to the error variant of the result. I hope that makes sense, and we're going to get to see how it works right here. We're going to say file.open, right? The same thing as before, the file path. Now we know that it's going to return a result. It can either fail or it can succeed. So we want to go ahead and handle that error right away with a map error, right? And we're going to take the error as a parameter, and we're going to pass it in, and we're going to say error.toString, right? So now we know that if there's an error, it's already been handled, and after that, we're going to do an and then, right? And then we're going to take the file, and we're going to blow it up first and say, let's see, let mutable content equal string new, and then after that we're going to take the file dot read to string, the same thing we've been doing this whole time, and it's gonna return a result. And so we're gonna need to handle that error as well. We're gonna say map error. Let's go down here. Map error, same as before, error dot to string. Okay, if not, we're not going to take in any parameter for this one, and we're going to leave the contents and return it back as an expression so that we can use it down here. And then we go and then take the contents, right, and then we're going to blow it up a little bit and say contents, let's see, let contents dot, we're going to trim it, right, and then we're going to parse it. 32, boom. And then if there's an error, we're gonna map error it. Error dot to string. Okay. File, what's going on here? File is a file, content string, read. Right, I'll get back to that. And then at the very end, we're gonna map whatever n is and return that as n2. Okay. Bind variable. File is mutable. Let mutable file. Okay, so now let's see how that looks. We're gonna go ahead and run this. I think case-by-case analysis, as well as using dot map error and then this is the reason why we're progressing to the final solution. I don't think these are very clean, and it's very confusing if you look at this code. I mean, like for example, look at the case-by-case analysis. This is very confusing to me. And then especially this was very hard to write, you know, trying to keep track of all the variables, all the closure, and what's being passed in and what's being returned back to the expression. It can get a little bit hairy, and so I don't like it, but this is the reason why we're progressing down the stages so that we can get to the final solution, which I think is the best and the most clean and most efficient way to handle these errors. So let's go ahead and run this now. Yeah. Okay, so as you can see, the error works just like before, just like the case-by-case analysis. It says invalid digit found in string. So we're gonna go ahead and take that out, and we're gonna make sure it works. Yes, it works perfectly. And if the file is incorrect, the file name is incorrect, it's gonna do the same thing, right? So basically, here's another way to write the exact same code, having the same exact results, right? All right, so that's the third way, and we're gonna go ahead and comment this out now. Okay. All right, so now we get to go to the fun part, right? And implement our own custom errors. To me, this is the best way to handle these errors, because if you really think about it, returning a string as an error is not very efficient at all. First of all, let's say if you have a bunch of different errors, and I know if you write a lot of code, you probably know what it's like, because I've done this in C, where I would put, I would just type out a random error for each individual one, and I'll be like, oh, cannot find a file, or oh, I cannot parse, or oh, the pointer is not something, and I just return the string, right? And I mean, that's okay, because the function caller can just take that string and maybe can print it out to the console, or like can show it to the user, so the user know exactly what the problem is. However, if you think about it, it's not very efficient, because if you keep injecting random string slices everywhere into your code, it can get very messy and dirty. And not just that, like every time you return a string as an error, imagine you have to compare, and you have to use string compare. Like for example, in C, you string compare just to see, oh, if this error says this exact string, then we'll do this. But what if you don't remember, like, oh, I don't know if it's cannot parse int or cannot parse float, I don't remember, right? So then now you're confused about that. You have to go look for the exact part where the code is, where you injected that string specifically, so that you can figure out how to handle it, right? Whereas if you have a custom enum that have all the different variants of each individual error, you can just call it based on its numerical order within the enum. and based on that you can see exactly how you should handle the error, and it also leaves you with a hub basically where you have all of your errors in one place, and if you need to add more you can just add more there. If you need to see exactly which one it is, you can just see it right there, right? So that's the advantage of having a custom error over using strings as errors, right? So that's what we're gonna do right now. We're gonna say enum CLI errors, okay? And for the first, these two, we're gonna say the first variant is gonna be just say cannot read file for any reason, right? And it's gonna be an IO error, so it's gonna be IO error, okay? And the second one is gonna be the parse error. So for whatever reason that we can't parse the string within our file, then we're gonna flash this error, and it's gonna be a num parsing in error, just like that, right? Pretty simple, right? So we have these two errors, and like I said, now you know exactly where all the CLI errors is gonna be, and if you need to add more, you just go straight here to your code, and you can just add as many as you like, or you can check to see which one it is, what it says, you know, which numerical order, like this one would be 0, this one would be 1 index, you know, so it's very convenient. So now that we have that, first of all, we want to make sure to put a debug derive on here so that it can be printed out to the console, and then after that we can change this. So now instead of using string as a fixed error, we're going to use CLI errors here, okay? And okay, so then with this one we don't have to retype this code, we're just going to copy it, okay? We're going to copy it because it's very similar, right? It's very similar in implementation, but instead of turning the error into a string in map error, what we're going to do instead is we're going to take that error and we're going to create a new CLI errors, and it's going to be, this one is going to be the IO error, right? So it's going to be cannot read file, and inside of that it's going to be the error, okay? And then this one here, where is it at? Right here, okay? This is also cannot read file, so we're going to say CLI errors cannot read file, and inside of that is going to be the error. We're going to wrap the error inside of cannot read file. And finally here, for this error, it's going to be the parse int error, right? And the reason why I know, guys, because the compiler is telling me that this is a parse int error, and that's how I know to make sure that I use the num parse in error inside of the parse error, right? Because I mean, it wouldn't make sense for me to put the IO error inside of the parse error, right? Because that's not going to be the error that's returned whenever a file is unable to, whenever my program is unable to parse a file from string into an int, right? It's going to return a parse in error. So I need to make sure that it's the correct form of errors being placed inside of each one of these variants, right? So here we're gonna say instead of error to string, we're gonna say CLI errors, parse errors, and the errors inside. Okay, so now as you can see, everything looks good, right? All right, let's see if it works, right? It should work the same exact way. For this one, because we are using a different error, we need to go ahead and use the debug function in order to print it out to the console, and let's see. All right, okay, so it still works the same. Now what happens when we have an error? This is the IO error. So as you can see, it also allows us to run other codes afterwards, so it didn't shut down, it didn't crash. It shows us the error cannot read file. We made that. That's a custom error on our part, so that's really good. And then the system cannot find the file specified, right? Or what if we put Batman in here? What happens? Yep. So error, parse error. That's our custom error name, and it's a parse in error, and the kind is invalid digit, right? So pretty cool. All right. So now once again, nothing changed. The code still do the same thing. So far we've been doing all of these running back and forth, you know, going through multiple versions, multiple ways to write the same exact code, and it's not making it any faster, but it's better. It's more professional and more efficient, in my opinion, right? Okay, so that's one other way. Okay, so we are going to keep using the custom error because ultimately that is the best way to do this. But what I'm going to show you now is a different way to where we can write this code a lot cleaner. Because, like I said, I don't like to use this type of it's just too much. It's too hairy. If someone doesn't know what's going on and they look at this code base, they're probably not going to be too happy reading this. So I'm going to show you guys a way to make this even simpler. Okay. All right. So we're almost done here. We're going to go ahead and comment this out. Okay. And so what we're going to do now is we're going to implement a new trait onto our errors, and it's going to be the error trait, right? We're going to say implement error for apply errors. And that's it. We don't need to do anything. We don't need to implement any function inside of it. It's already been basically pre-made for us. It's very convenient. It comes for free. So what it does is it allows us to use the question mark operator to bubble up any errors that we might have, and it'll convert it. Well, we have to convert it with map error first, and then we can just bubble it up instead of doing all of this nonsense right here. Okay, so what's the error that we have right here in this CLI error? We need to implement display first, right? In order for us to implement error, because it needs to be a display trait. So we're going to implement display for CLI errors. Yep. Okay, and for this one, it's going to tell us. I'm going to find try display. Oh, okay. It's going to be FMD display, FMT display, right? Is it FMT? Or is it which one is it? Yeah, it's FMD display. Okay, and then it's going to want us to implement the function, the FMT function, and I'm going to copy the beginning of the function because it's very let's see, function FMT, and it's going to take in a self. I think it's going to be an FMT. What is it? It's something, and it will return FMT result, if I remember correctly. Right? What is it? Where's the FMT function? Oh, here we go. Copy that. I don't think I need that. A lifetime. Okay, so then we can use this, and for now I can just I'm just gonna say unimplemented for now. We'll get back to it. Okay, so now we have the display trait being implemented for CLI errors, so then now we can have the error for free for CLI errors. So like I said, what that does is allow us to bubble up any error into the without having to do all of these write all these codes. So I'm just gonna copy this right here, this part of the code, because it's gonna be very similar to it. And we go here, uncomment it. Okay, so now instead of unwrap, what I want to do first is just map the error, right? So we're gonna go inside of error variant and map it into the same thing we did earlier, right? Into a CLI errors, cannot read file, and then it's gonna be the error. Right, we're gonna do that. Okay, and then here the same thing. Instead of unwrap, we're gonna say map error, error CLI errors, cannot read file, error. What's going on? Error CLI errors, cannot read file, error. Expected what? File.restring.map error. Read to string file. Okay, so the reason why is because I didn't use a question mark operator, so then that's gonna bubble up any error. It's gonna basically be an early return, but if not, then we'll get our file back. And the same thing here, right? It's gonna be CLI errors. I misspelled something. Oh, there it is. All right, so then finally right here, we gotta wrap that inside of an OK variant. Okay, and this too. Instead of unwrap, I wanna say .map error CLI errors, and it's gonna be parse errors, and the errors is inside, and then question mark to bubble up any errors. Okay, so that should work. Once again, everything should work the same, no changes. Okay, and if we have the wrong file name right there. Cannot refile, same thing as before. Nothing changed, guys. Right? I'm just trying to show you that these are all different ways to write the same code. Parse error. Okay? So, perfect. So right now, as you can see, this is, to me, this looks a lot better than everything else already. Right? Look at this. So the first version that we wrote, we had to use unwrap. That's really bad. So that's out, right? And then this one, we were having a lot of case-by-case analysis here, a lot of matching, a lot of arms, you know, very confusing, right? I didn't like that. And then here we have a lot of map.error, and then we didn't know which arm to use, and we didn't know which closure to pass back and forth, and all of that. That was confusing. Same with this. And this one to me looks pretty good. Looks pretty good. But you know what? There's one final thing that we can do in order to make this look even cleaner, if you believe it or not. All right, so what I'm looking at right now is this map error. I don't even like this, right? How do we write our code so that we don't even need to use map error? I want to just bubble up any error I might have, and I don't want to have to use map error. So how do we do that? How do we make it so that this question mark operator can convert whatever error it is that we may have, convert it back into the correct variant of that error, and then just bubble it up? How? How would it know what to do with our custom errors? These are custom errors that we wrote. How would the compiler know to convert it to the right errors? Now that sounds crazy, but it's not. There's a magic little function called from. So from is a trait that you can use, and if you implement the trait from onto the variant of your custom errors, the question mark will be able to use that and convert whatever errors that might pop up into the correct error, and then bubble it up. So you won't even have to use map error, and that's what we're gonna do right now. Okay, so we're gonna come here and we're gonna say implement from, and we need to pass in whichever type generic it is that the from is gonna be. So this one in particular is gonna be io dot errors, right? Yeah, for cli errors. Okay, and we're gonna have to implement the from function here, and it's gonna take in a self, I believe. Wait, no, it's gonna take in a hold on one second. From io error, yeah. Okay, so it takes the error in, right? And then whichever it's gonna be, this one is gonna be io error, right? And it's gonna return a self. A self is basically a cli error. So we're gonna say if it's an io error, the from is gonna convert it into a cli error by wrapping it inside of a variant of the cli errors. It's gonna be cannot refile, and within it, it's gonna be error, just like that. And we're gonna do the same exact thing for the other variant of our custom-made cli errors, and this one is gonna be num parse errors, parse int error, right? And it's gonna be the same thing down here, and we're gonna pass the cli error, we're gonna pass that error up. This is gonna be parse error. Okay, so just like that, guys. So if you have more variant, if you end up adding more variant into this enum, then you're gonna have to implement a from for each one of them, so that the question mark can look and know exactly how to convert it, right? So now that you have these in place, guess what? You can go down here, and I'm gonna comment this out, right? I'm gonna copy it first and then comment it out. And here's the final version of our error handling, okay? Look, watch. Map error, boom. Map error, boom. Map error, boom. Look at that, guys. Look at that. So let's test it out first. Let's make sure that we're not getting ahead of ourselves. There you go, result 200. So what happens when when it's the wrong file name? There you go, cannot refile, system cannot find a file specified. Parse int error, invalid digit. So as you can see, Everything looks the exact, everything works the same, but look at our code now compared to what it was. Look at that. Look at our code. Look how clean that is. You just open the file. If there's any error, just bubble it up. The compiler already know how to convert that error for you because you did all the work here, because of all the electrical wiring you basically set up beforehand, right? So you wrote all these codes, you implemented all these traits so that you can have a cleaner function down here, just so you can have cleaner code here. Same with the content. We create a new string, and then we read to the string, and we just bubble up any error. And then finally, we just bubble up any error. If we have any parsing error, we just bubble it up, and then we return an okay variant of the result. And that's it. Look at the difference here. Look at the difference. So here, using unwrap. Here, we use case-by-case analysis, right? Here, we use the map error, right? And then here, we use with the string errors. And then here, we use the map error with the custom-made CLI errors, right? And then here we use the map error but slightly cleaner and the question mark operator. And then finally here we have our final version, final form of this code. And in my opinion, this is the cleanest, this is the best. I love it. It looks really cool. And like I said, if you want to add more errors, you just do it here, and then you just add another implementation for that particular variant of the errors. I mean, doesn't get any cleaner than that, in my opinion, right? And of course, if you want to display like a pretty looking display here, you can do that too. Because remember, when we didn't implement the display for CLI errors, what we could do is just say match self, right? And it's gonna be whichever arm it is, right? So if it's gonna be cannot refile, CLI errors cannot refile, then we're gonna say we're gonna take the error and write. We're gonna write to that F formatter, cannot read file properly, right? And then whatever the error is, just like that. And the same thing, we have to pass this in as a ref. And the same thing is gonna go for the next variant here, right? This is parse error, cannot parse file properly. Okay, so now that we have this implemented somewhat, you can take off the debug function and just let it print out normally. And if you look, it's a lot prettier in my opinion, because we get to customize how our error code is going to look, right? How our error message is going to look. So here we go. If we have the wrong name, file name, look at that, error cannot refile properly, the system cannot find file specified. Psh. Perfect, right? Or if we go here, we put Iron Man here. As you can see, error cannot parse file properly, invalid digit found in string. Perfect. So this is probably the best version that we have, right? This right here, this code right here. So delete everything, and there you go. Look at that. Like I said, it's not making the code any faster, it's not making it any more efficient. It's just nicer to read, cleaner to read, and just looks a lot more professional, a lot easier to implement more errors, variants in the future. It's better to have everything in one place. Future developers can just look at your code base and they know exactly what's going on, and they would appreciate you pretty much for setting things up for them down the line. And I think that's the beauty of error handling. And to be honest, I never thought it was that important until now. And I think this is part of becoming a better software engineer. It's just like learning the nitty gritty of stuff that you thought was not that useful or not that pretty or not that, sexy, pretty much. Doing things that are a lot more tedious than usual, and just, putting in the time to understand code and understand, basically how to implement certain things and how to go about it the right way, right? The correct way, or not, maybe not the correct way, but the more standard way. So I hope that helps, guys. This is error handling in Rust. If you guys like me to go over any other topic in Rust or any topic in C, just leave a comment, let me know. And I'm really happy because doing these videos really helped me a lot understanding these concepts as well. So with that being said, Merry Christmas, everybody. Hope you have a great, Happy New Year, and I'll see you next time.